Welcome back, everybody. Let's continue now with part 2 of our lecture on chapter 2. I left off last time talking about how all maps have to have a coordinate system, and we looked at different types of coordinate systems you may have used before. However, in geography, in geographic education, the most important coordinate system, the one that's most commonly used, is the system of the parallels of latitude and the meridians of longitude. Let's take a look at some figures from your textbook and a few others that I've collected for you as well. All right, you have these imaginary lines that run across the globe. You have those that run east-west, and you have those that run north-south. Well, the ones that run east-west, those are the parallels of latitude, whereas the ones that run north-south, those are the meridians of longitude. Now, one way to visualize the system of latitude and longitude that uh, gives the absolute location of anything on Earth in angular degrees north and south of the equator is, imagine if you had a protractor that you could put inside the Earth. If you could hack open the Earth, slice it up, and you could put a protractor so that it lines up with the equator, and then kind of eyeball the globe and ask yourself, well, where are we located in angular degrees? If the equator is 0 degrees and the North Pole is 90 degrees, where are we on that protractor measurement? Well, let's see. Come up here. This is 30 degrees north. Now we got to go a little further. How about this one? It goes up to 60 degrees north. No, that's too far. We're located here in southeastern North Carolina. If we had a protractor in the center of the globe and we looked at the angle that it made, we're located at about 35 degrees north latitude. All right, and then if you followed that line all across the globe, you could say that we're on the 35th parallel. All right, and then longitude, well, if you could hack open the globe and you could put a protractor in there and then measure from the decided upon prime meridian the degrees east or the degrees west. If you, well, let's see, we're not open enough on this figure, but if you brought it along, we're somewhere around 79 degrees west longitude from the prime meridian. Okay, now I've prepared a number of other slides for you to hopefully recap all of that for you. So I have several examples and also some of the importance of understanding the distinction between latitude and longitude. Let's see, to distinguish between the parallels of latitude and the meridians of longitude, well, the parallels of latitude are those lines that run east-west across the globe, but they give your position in absolute location in degrees, minutes, and seconds, either north or south of the equator. Quick, what's the lowest possible latitude that you can have? Yes, 0, that's the equator. What's the highest possible latitude that you can have? That's either the North or South Pole. That's 90 degrees. Okay, so the parallels of latitude, then they give your position on a scale of 0 to 90. That's different from the meridians of longitude. The meridians of longitude are lines of the globe grid system that run north-south across the globe, but they give your absolute location in degrees, minutes, and seconds east or west of the prime meridian. One of the important things to see about latitude versus longitude is that the parallels are just that. The parallels are parallel lines. they never come together. Okay, and the distance between each degree of latitude is always the same. It's about 69 miles. One of the differences between latitude and longitude is also the latitude lines that run east-west across the globe. They get shorter as you go towards the poles. Here, this is along the equator. That's as long as you're going to get. And then the North Pole is technically a line of latitude, but it's a point. And that's a very small line, but it's a point. But it's also a position of latitude. All right, and these are, once again, these are parallel lines. Well, how do you like your oranges cut up? Do you like to have your oranges cut up longitudinally, or do you like to have your oranges cut up latitudinally? I think for eating purposes, I prefer to have my oranges sliced up longitudinally, and if I was going to put them on the edge of a drink glass, I think I would prefer to have them sliced latitudinally. All right, so that's an analogy, one way to look at these. Okay. The next thing that we're going to discuss is, well, how far is it across a degree of latitude? Okay, well, if you were to walk from the 35th parallel, which Pembroke is almost on, and you were to walk north to the 36th parallel, how far would you have to walk? Well, it's about 69 miles, or 111 kilometers. In nautical terms, it's 60 nautical miles. And have you ever wondered why is it that we use a different mile at sea than we do on land? It's the statute miles, the regular old miles that you're used to using. And they're 60 nautical miles. All right, well, why is that? Well, that's going to come up in our discussion here. There's an important reason why. All right, so the distance between each degree of latitude is about 69 miles. Well, what if there was a pirate treasure that you had the coordinates of a pirate treasure, and it gave you just the rough degrees of the pirate treasure? Well, you know that treasure is somewhere in a swath of 69 miles. That would be a lot of holes that you would have to dig in order to try to find that treasure. Well, in order to more precisely give the location of anything, each degree can be broken down into 60 minutes. Right? Now, you can kind of make an analogy for time with using these degrees and minutes. If it is halfway between 9 o'clock in the morning and 10 o'clock in the morning, what time is it? Well, it's 9 hours, 30 minutes. Well, what if you're exactly halfway between the 35th parallel and the 36th parallel north? Well, you'd be located at 35 degrees 30 minutes, because each degree is divided into 60 parts called minutes. Well, now you can locate a place a lot more precisely if you're locating a city then because each minute of latitude covers a distance of 1.15 miles. All right, if you take that 69 statute miles divided by 60 minutes, you get 1.15 miles, or 1.85 kilometers, or 1 nautical mile. And that's the reason why you have nautical miles. A nautical mile is a minute of latitude, assuming a spherical Earth. Okay, and that's another story for another time. All right, so but if you're looking for a treasure, well, 1.15 miles, that's still a lot of holes that you would have to dig. So every minute of latitude can be divided into 60 parts called seconds. And so it's kind of analogous to the time, minutes and seconds. You have divided into 60 parts. Every minute is divided into 60 parts called seconds. Now the distance across a second of latitude is 101 feet, or 31 meters. So that much more precisely gives your position of latitude. You know, latitude was fairly easy even for the ancients to find. One of the ways that you could get your latitude, say if you were in a boat somewhere out in the open ocean, and you wanted to know, well, how far north or south am I? One of the things that you can use is the North Star. And here on this little animation, I'm pointing to where the North Star is. The North Star, Polaris, is directly over the North Pole. And so at night, all the other stars spin around Polaris. All right? Well, here's a very handy thing. The angular degrees that Polaris is above the horizon, that's your latitude. So if you're somewhere in the open ocean and you see where the North Star is, right, and you see that the North Star is 25 degrees above the horizon, you know what your latitude is? 25 degrees north. Or if the North Star was 55 degrees above the horizon, you know what your latitude is? 55 degrees north. So it was always easy, even the ancients knew where they were in latitude. At my house, I could look down my driveway, and the North Star is 35 degrees above the horizon there. So I know I'm located at 35 degrees north. This leads to the question of what was latitude sailing, and what were some of the advantages and disadvantages of latitude sailing. Now, latitude sailing was especially common during this age of exploration, the European voyages of discovery and colonization of the New World. Latitude sailing was frequently used. Well, one way that it was used is that, say you needed to get to an island in the Caribbean, and you knew that the island was located at 22 degrees. Well, all you had to do was go north or south until you had Polaris 22 degrees above the horizon, and then just sail east or west. Well, if you're going to the Caribbean, likely you're sailing west, and you know the sun comes up in the east and sets in the west, so you know which way you have to go. You just stay on that 22-degree line until you run into your destination. All right, so using Polaris and other astronomical methods were used to guide sailors. Longitude was a lot harder to figure out, as we'll see. All right, well, what's longitude? Well, that's your angular position east or west of the Prime Meridian. Now, here's one of the other distinctions between latitude and longitude. What's the highest possible latitude? 90. But how about longitude? It's 180. Okay, your highest possible longitude to go from one side of the globe to the other. is 180 degrees east or west. Also, here's another one of the distinctions: the distance between the meridians decreases towards either poles. You can't ask the question, what's the distance across a degree of longitude, uh, uh, because it varies. Right at the equator, 69 miles, but then at either pole, it's zero. So the amount of distance between each one of the meridians gets smaller and smaller as you go towards either pole. Now the prime meridian is a starting point here. It's not a logical starting point. It's logical. It's just because it's internationally agreed upon that the prime meridian runs through um, Greenwich, England, the Royal Observatory, and here it is demarcated actually on the landscape. Okay, and we're located about 79 degrees west. We're in the Western Hemisphere. All right, so yeah, hemispheres. You can split the world into two hemispheres, but you can split the world into two hemispheres in two different ways. You can divide it north-south, and you can divide it east-west. So Pembroke is located in the northern hemisphere. We're not in the southern hemisphere. And we're also in the western hemisphere. We're not in the eastern hemisphere. Sometimes other famous parallels and meridians come up when you're talking about the environment and history and so forth. As we'll see later in the course, there are some other very important reference lines. You have the two tropics, which the Tropic of Cancer is 23.5 degrees north, and the Tropic of Capricorn is 23.5 degrees south. So if you're within those two lines, then you're within the tropics. Now, when I was in elementary school, I always hated it that the tropics started at 23.5. Why 23.5? Why not some nice round number? Why can't the tropics start at 20 or even 25? It's a solid number. But there's a reason why. It has to do with Earth-Sun relationships, and this will come up in Chapter 4. All right, so you have the equator, you have the two tropics, and then you also have the circles. You have the Arctic Circle at 66.5 degrees north, and the Antarctic Circle at 66.5 degrees south. And again, when I was in elementary school, I hated it that the Arctic started at 66.5. I always wanted it to be a nice round number. Well, why can't it start at 60 or something like that? Well, it has to do with Earth-Sun relationships, and again, this will come up in Chapter 4. All right, and then the two poles are very important parallels, although they're also points. And then the very important meridian is the prime meridian, which is internationally agreed upon. Okay, here's a little practice quiz, which I wanted to go around the classroom and ask everybody, can you answer these questions? These are some matching here. These actually come up more so in Chapter 4, so I'm not going to spend much time on it here today. Another important line, if you will, that's an important part of the global grid system, is the international date line, where the new day comes in. It's fortunate that the prime meridian that runs through Greenwich, England, is the origin point for longitude, because where it puts 180, where you switch over east to west again, is in the relatively sparsely populated Pacific Ocean. Is where you have the 180 line. Now, the date line zigzags around, though it's not exactly a straight line all the way down the 180th meridian. It zigzags around major island groups to keep the same country all in the same day. And that means that there would be less confusion. Size and shape of the Earth. There's an entire subfield of geography and cartography and engineering called geodesy, which just looks at one thing, and that's the shape of the Earth. Now, you might think that's a pretty easy science because you just say, well, it's round, right? But sometimes, and in some sciences, you need very, very accurate Earth shape information. Oh, you have this slight bulge at the equator of the Earth, so that the polar circumference is slightly different than the equatorial circumference. Oh, you have mountains and ocean basins and rocks of different densities and so forth. And so sometimes for very, very precise mapping, and if you want to do something like get involved in guided missile design and so forth, sometimes you need very, very accurate Earth shape information. And there's a whole subfield of geography called geodesy that examines some of the subtleties of that. That would be beyond Geography 1010. In case you pull the quiz question about this, it's Eratosthenes that we credit for the Earth's circumference, and it's Ptolemy that we credit for giving us the global grid system. Related to the subject of looking at the meridians of longitude, another part of the story is knowing how our time zones work. Now, likely, if you do a lot of cross-country travel and international travel, you know that the time zones are different in different places. And you would probably have an app on your cell phone that would tell you what the time was whenever you landed in another place. But I would like you to understand how the time zones work. Now, on Canvas, in the Chapter 2 module, I have a copy of the time zone map there, and you could print those out. And if you're going to be a school teacher, I suggest making copies of those and passing those out to students and looking at a few examples. I mean, and you pick a day and a time, and you label it on the map, and then ask them to put the time and date, or time and day, on all the other places in the world. And you can see how the time zones are different. Usually I like to do this in class and go around the classroom and ask people what time it is. All right. Here, one of the things to keep in mind for the time zones, let's say, how are they set up? If you want to have 24 hourly zones, then you have a different time zone about every 15 degrees of longitude. Okay, so that's what each one of these lines represent. All right, that's a 15-degree swath. It straddles the Prime Meridian, so you have 7.5 degrees on one side, 7.5 degrees on the other side, and then after that, it's every 15 degrees. You have a different time zone. Well, how does it work? Well, if you can keep in mind that the Earth rotates to the east and the sun comes up in the east, it's always going to be an hour later in every time zone to your west. Okay, so for example, and you can substitute in a number of times for these, if it's, let's say it's 11 o'clock in the morning in Pembroke. Well, what time is it in New York City? Well, it's still 11 o'clock in the morning because we're in the same time zone between Pembroke and New York. Okay, so if it's 11 o'clock in the morning in Pembroke, what time is it in Chicago? Well, then it's an hour earlier. All right, and so that means it's 10 a.m. How about in Denver? Then it's 9 a.m. And how about out in California? Then it's 8 a.m. And so you just keep going. Okay? You subtract an hour. Now something funny happens though at the international date line. At the international date line, the day is always 1 day later here on this western side of the zone than it is on the eastern side. It's always a day later. You always add a day to the date. Now, here's something that's also funny about it. It's within the same time zone. So you're within the same time zone, except that the time doesn't change in that zone, but the day does. I always like to give this example in class. Let's say that you were out in a boat or out in a yacht somewhere here in the Pacific Ocean, and let's just say it's Sunday at Sunday 9 o'clock in the morning. Okay, you're there. It's 9 o'clock in the morning. The sun is in its position in the sky. You know it's 9 o'clock, and your boat drifts over the international date line at 9 o'clock. Well, what time is it? It's still 9 o'clock, but it's not 9 o'clock Sunday anymore. It's 9 o'clock Monday, and so you go, oh no, I missed church. Well, you know how you can still make it? Okay, well, travel back to the Sunday side, and now you're back to 9 o'clock Sunday, and you can probably still make it. All right, the best way to do this, and if you're going to be a teacher, is to make copies of the diagram, pass them out, and then try some different times. All right, I'd like you to understand how the time zones are supposed to work. Time depends on longitude. Here I've summarized that information for you. A couple other things that you're going to run into is the term GMT. That's the Greenwich Mean Time. Sometimes on various websites and other references, they show you what the time of the photograph of the image is, and it may not be for your time zone. Sometimes they put a reference on there where it's GMT. That means the time at the Prime Meridian, the time in London. Okay. Well, remember the ancients. If they were navigating out on the open ocean, they were always able to figure out where they were in latitude by using astronomy, either by using Polaris or looking at the sun angle on particular dates and keeping charts of that. It was always easy to find your latitude. But how could you find your longitude, though? When you're out in the open ocean, how do you know how far it's been? How far have you traveled from the port? You would know, and that was one of the problems with latitude sailing. Yes, you could if you knew what degree your island was located at, so it was 22 degrees. I could just sail 22 degrees, then sail west until you run into it. That was a problem. And that the sailors were running into these things and dashing up upon rocks in the middle of the night, because while everyone knew where they were in latitude, no one knew where they were in longitude. And that's why a lot of these historical maps, antique maps, they're very strange configurations of the continents, because longitude wasn't known. So imagine that it's the 1700s and you're navigating a ship somewhere in the Atlantic Ocean. Well, how could you figure out your longitude? There were various methods that were tried to this, and basically it comes down to guessing. There is a way to figure it out using phases of the moon, but you need a computer to do that. It turns out that the easiest way to fix your longitude is to look at the time difference. Okay? If you had an accurate clock that could keep time at sea. Now, before the 1700s, clocks existed, pendulum clocks, water clocks, and so forth, but they wouldn't keep accurate time at sea. You needed to have a clock that would keep accurate time out on the heaving ocean. All right, and so the clockmaker Harrison invented the chronometer, and so then our maps could begin to take shape. So let me tell you how it works. Say you know where your latitude is. We'll give you that. All right, so let's see. If you figure that it's 12 o'clock noon local time on the ship, so you're watching the sun go through the sky, and you figure, well, it's zenith for today, because after that it would start to going down after that. So you say, okay, it's 12 o'clock noon local time, but you look on your chronometer and it says it's 2 p.m. back in London, so you have a 2 hour time difference. And so, we'll see an hour of time for for each of the 24 zones. So 15 plus 15, you must be 30 degrees west. All right. If you're 2 hours earlier, again, it's hour earlier in each time zone to your west. So if you're 2 hours earlier, you must be on the 30th meridian, west longitude. All right. And here's an extra question in there. This one's directly from the book. Sometimes on some websites and some devices, they don't give the latitude and longitude location in degrees, minutes, and seconds. Sometimes they use a decimal of degree. For example, you may have a latitudinal position of 35.5. Well, what does that mean? 35.5, so it's 35 and a half. That would be 35 degrees, 30 minutes then. Okay, I notice a lot of these systems, you have the Eastern Hemisphere, those are positive numbers, and the Western Hemisphere are negative numbers. And, the Northern Hemisphere are positive numbers in latitude, and the Southern Hemisphere are negative numbers. Yes, we know that type of thing exists, and we try not to let that bother us. Some of you may be familiar with latitude and longitude by using a global positioning system. Um, when I first started teaching this class, no one knew what a GPS was, but these days most people have a GPS in their cell phone. Stands for Global Positioning System. So anytime anybody needs very, very precise latitude, longitude, and elevation information, then they would use a GPS. In your textbook, they use this term called geocaching. All right, that there used to be this game where it would be published on teacher would publish on a website the latitude and longitude location of a treasure out in the woods, and it would challenge students. Okay, go and find that treasure using your GPS and these coordinates. All right, and then you're supposed to then sign in and say that you were able to find that. Okay, it's a game that's sometimes played in geography or environmental science. The global positioning system is a system of satellites that can give very, very accurate information, latitude, longitude, and elevation. And also the GPS system is integrated into navigation systems. So it's a lot harder to get lost these days. I sometimes think, where would we be without the GPS navigation systems on our phones? Okay, it's a system of many satellites. I'm including a reference here. This is for the engineers only. This is really beyond geography. 1010. I will tell you, though, that we do offer courses in some of these geo technology sciences. I encourage you to find out about those. For me, how does a GPS work? Well, I turn the device on and I look. Now, are there other coordinate systems that are used by professionals in environmental science, research, government, industry, and so forth? Yes, but those are way beyond what we will do in Geography 1010. So I will end up at this point.